This is the phase diagram of a partially saturated soil sample. Void ratio of this soil sample is defined as the ratio of the space occupied by the voids, that is volume of voids, to the space occupied by the solids, that is the volume of solids. And decently, we can also write volume of solids as total soil volume minus volume of voids. It is not expressed in percentage like water content. Loose soils have relatively high volume of voids, hence in the equation they have high value of the numerator and hence higher value of void ratio. If the same soil is compacted and made dense, it will have relatively small amount of voids, which will make its numerator small and will result in lower value of void ratio. So for the same soil, if it is loose, we will have a high value of void ratio, while if the soil is dense, we will have low value of void ratio. We should note here that every soil will contain some voids in it. It is not practically possible in the field, I am not sure about the lab, to have voidless soil. Hence, there will always be some non-zero value of volume of voids. So void ratio can never be equal to 0 and will always be greater than it. So what are the applications of void ratio? Well, there are several benefits and applications of knowing void ratio. By knowing the void ratio of soil sample, we may have better control over volume change tendency of soil. If void ratio is high, that is soil is loose, then under loading voids have a tendency to minimize themselves. So for soils with high void ratio, civil engineer may take a decision either to reduce the loading or pre-compact the soil. Again, if we know the void ratio of a soil sample, we have better control over fluid conductivity and particle movement through its pores, as loose soils show high conductivity while dense soils are not so permeable.